Hello everyone, welcome back to my channel. In this video we are going to learn the topic salt analysis. This is part 4 of the salt analysis series. So if you have not yet seen the other parts, I will give the links in the description box below and you can watch those videos before watching this one. So in this part, we are going to learn the confirmatory tests for cations. Now in the previous part, that is part 3, we looked at the identification tests. So now we are going to learn how to confirm whether our identification is true or not. So in order to confirm the identification, we have to perform confirmatory tests. And most of the cations have two confirmatory tests. And there are two very important tests which we need to learn, and I will tell you those in the beginning itself. So the two tests that are very important are the flame test and the ash test. So I'm first going to explain this in the beginning itself so that when we are reaching the cations which involve these tests, it will be easier for us to understand. So what do we mean by flame test and ash test? Now, if you remember in part 1, I told you that in the preliminary observations, you have to write the flame test as well. However, it is not mandatory to perform it in the lab, but you have to write it in the beginning. So now I'm going to explain what is the flame test. Now, first of all, the flame test is applicable only to group 5 cations, and the ash test is applicable only to groups 3, 4 and 6. So for groups 0, 1 and 2, you cannot perform these tests. But for groups 3, 4 and 6, you can do the ash test. And for group 5, you have to perform the flame test as one of the confirmatory tests. So now, what is the flame test? The flame test is very simple. You need to take the salt in a watch glass and you have to add concentrated HCl, concentrated hydrochloric acid, and then you need to take a glass rod and rub the salt and the HCl acid, and you have to show that mixture to the blue flame. So you have to show that to the flame. That means you have to heat that, and you will be able to see that the flame has a characteristic color imparted to it. So the salt would impart a particular color to the flame, and that will help us identify which ion is present. So it is very simple. Just take the salt and add concentrated HCl and make it into a paste and show that paste to the blue flame with the help of a glass rod. Actually, you need to use a platinum wire, but in the lab, maybe you might not have platinum wire. So something which is easily accessible is the glass rod. And of course, glass also can impart a yellow color to the flame. However, if you are soaking the tip of the glass rod well in the mixture, then the color of the flame will be correct. So you don't have to worry about getting a wrong color if you are dipping the glass rod properly. The second test is the ash test. Now, what is ash test? You have to take the salt in a test tube and you have to add concentrated nitric acid. Concentrated nitric acid, that is HNO3. And you also have to add cobalt nitrate solution, CONO3 twice. Okay, cobalt nitrate solution, and you will get a solution after adding all these chemicals. Now you have to first heat this mixture, and after you heat it, you need to take a piece of filter paper. You will have filter paper or some kind of a paper strip in your lab. So whatever paper is there, use that paper and dip it in this heated solution. And once you are dipping it, you need to take a watch glass and you need to show that that filter paper soaked in the solution to the blue flame. So once you show it to the blue flame, you will notice that the paper will start to disintegrate, and you have to collect that paper in this watch glass. So you will get the paper in the form of an ash. So it will disintegrate and it will become like a powdery ash, and there will be a characteristic color to the ash, and that will indicate which ion is present. So these are the two important tests which we need to perform under the confirmatory tests, and it is important to write these well in your written work. So now we will begin with the confirmatory tests for all the group wise cations. So now first we have group 0. In group 0, if you remember, we discussed in the previous part, we have ammonium cation. So first, what is the major test that you need to perform? It is the Netzler's reagent test. So you need to take the salt solution and you need to add Nessler's reagent to it. Nessler's reagent. And when you are adding Nessler's reagent, if you are getting a brown colored precipitate, then that means ammonium ion is confirmed. Now, what is this brown precipitate which is formed? It is known as iodide of Millen's base. We call it iodide of Millen's base. Millen's base. Or you can also say basic mercury amido iodine. There are two names. The second one is a chemical name, basic mercury amido iodine, and the common name is iodide of Millen's base. And the precipitate has a formula. The formula is NH2HgOHgI. This is the structural formula. Of course, you can condense it and get the molecular formula, but normally we prefer writing it this way so that you can see the bonds clearly. And what is Nessler's reagent? That is another Viva question. Nessler's reagent has the molecular formula K2HgI4, and in the chemical name of this would be potassium tetraiodmercurate. That is the chemical name. So there are four iodines, that is why we are writing tetraiodo, and there is mercury, which is why there is mercurate, and because there is a potassium ion, we are writing potassium. So that is the chemical name of Nessler's reagent. This is the first confirmatory test. The second confirmatory test involves the salt. So you need to take the salt in a test tube, not salt solution, just the salt, and you need to add NaOH solution. And when you are adding NaOH, after adding it, you have to heat it. You need to heat it, and when you are heating, if you are bringing a test tube, not a test tube, a glass rod dipped in concentrated HCl. Okay, see, I will explain again. You need to take the salt first, and then you need to add NaOH. So you will get a solution. And once you are getting the solution, you need to heat it. After heating, you need to bring a glass rod which is dipped in concentrated HCl. It should be dipped in concentrated HCl, and you need to bring it near the mouth of the test tube. So you have to place it like this. And when you are doing so, if you are able to get the smell of ammonia, if you are getting ammoniacal smell, and also if you are getting white fumes from the test tube, if you are getting white fumes, then that means ammonium ion is confirmed or it is present. So this is the second confirmatory test. Now let's learn the chemistry behind the reaction. So when you are bringing the glass rod dipped in concentrated HCl near the mouth of the test tube, you are actually getting NH4Cl gas. Ammonium chloride gas is liberated, because of which you are able to observe the smell of ammonia. That is why you're getting ammoniacal smell, because in NH4Cl you are having ammonium ion. And also the white fumes which are being produced are actually NH4Cl fumes. So that is all about the group 0 cation, that is ammonium. Now we have to talk about the group 1 cation. Now in group 1 we have lead, Pb2 positive. Now Pb2 plus, the confirmatory test is actually very simple. Now I would like to give you a clue. For the confirmatory tests of cations, in all the confirmatory tests, you need to dissolve the precipitate in something and add a chemical to it. So all the confirmatory tests will involve the precipitate. And what precipitate? You have seen the part 3 video where I had told you the identification tests for all the cations. In that I told you each and every ion has a precipitate formed, except for group 0 and group 6 as well. Group 6, you can do the ammonia hyperphosphate test, but of course that is not compulsory. Normally if you are not getting any of the group 0 to 5 cations, then we just assume that it is group 6. So normally for group 0 and for group 6 there is no precipitate. So except for group 0 and group 6, if you see in the identification tests, all the tests involve a precipitate. There is a precipitate being formed. So that identification precipitate has to be used for the confirmatory tests. So you have to dissolve that precipitate in a particular solvent, and once you are dissolving it, you need to add certain chemicals and see what is the characteristic change. So like that, for group 1, you have to use the precipitate that is formed. And if you remember, the precipitate that was formed is actually lead chloride. That lead chloride precipitate has to be taken, and you need to dissolve it in water. For group 1, the solvent that we are using is water, and then you need to heat it. So you are boiling the PPT with water, and you have to divide it into 2 parts because we are going to do 2 confirmatory tests. For the first test, we are adding potassium chromate. Potassium chromate is K2CrO4. For the second test, you need to add a few drops of potassium iodide solution. Now for the potassium chromate test, if you are getting a yellow precipitate, that means lead ion is confirmed, and the precipitate that is formed is PbCrO4. PbCrO4 is lead chromate. Then the second confirmatory test is adding Ki to the precipitate dissolved in water. And if you are adding Ki, you should again get a yellow precipitate. But listen carefully, when you are writing it, you need to mention something known as golden spangles. So the yellow precipitate, when you are dissolving it in water and boiling, the golden spangles should not be visible. But once you are boiling the PPT and you are bringing it out into the normal room temperature, the temperature has been lowered. So on cooling, you will be able to see certain golden spangles. That means there will be golden marks on the precipitate. So if you are getting a yellow precipitate with golden spangles on cooling, which disappear on boiling, then that indicates that lead ion is present or confirmed. So now what is the yellow precipitate formed? It is lead iodide PbI2. So that is the precipitate. Now let's move on to group 2. Now for group 2, again we need to use the precipitate itself. The precipitate is copper sulfide or cadmium sulfide, if you remember. We discussed that in the previous part. Now in the group 2, for the group 2 cations, you need to take the precipitate and dissolve it in dilute nitric acid. Preferably, you need to use 50% dilute nitric acid. But in your lab, if you're just having dilute nitric acid, then you can just use that. Or what I would recommend is, if you don't have 50% dilute nitric acid, you can very well use just dilute nitric acid. But if you want to do the test using 50% dilute nitric acid, you can just take dilute nitric acid and I'm sorry, I had to pause the recording in between. So I'm continuing now. So I was talking about the group 2 PPT. So first you need to take the precipitate and add 50% dilute nitric acid. So what you need to do is you need to take the dilute nitric acid in a test tube and add equal amount of water in it in case you are not having 50% dilute nitric acid. But in case you are not doing that and you are just using dilute nitric acid as it is, then also this test will work. Now then you need to divide this into 3 parts. So we are doing 3 tests, so you are going to divide it into 3 equal parts. And in the first part you need to add NaOH drop by drop, and then you need to add it in excess. First you have to add drop by drop, then you start adding it in excess. So if you are able to see a light blue PPT, or if you are able to get a white PPT, that means the group 2 cation is present. The light blue PPT indicates that Cu2 plus is the ion, and white PPT indicates that cadmium ion is the cation of your salt. Now, the light blue PPT that you get, if you are adding excess NaOH, then you will see that there will be a deep blue coloration in excess when you are adding it in excess. So, that is the test, the first confirmatory test. The second confirmation test is by passing H2S gas through this mixture. When you are passing H2S gas, if you are getting a yellow precipitate, that means cadmium ion is present. You cannot do the H2S test for copper. This is applicable only to cadmium. The third confirmatory test is only for copper, not for cadmium, and this one is nothing but adding acetic acid, and also you need to add potassium ferrocyanide. Potassium ferrocyanide is K4Fe FeCN6, and FeCN6 is a coordination entity. So potassium is acting as a counter ion, and this entire potassium ferrocyanide solution is actually a coordination compound. Now, when you add these two chemicals to the precipitate and nitric acid mixture, if you are getting a chocolate brown precipitate, that means a brown colored PPT, then that means copper is confirmed. Now we need to learn the chemistry behind the reaction. That means we need to discuss what are the precipitates. So here the light blue precipitate in the first test is CuOH twice. That means cupric hydroxide. And I told you the light blue PPT, it actually, when you're adding excess NaOH, you will be able to see deep blue coloration. That coloration is because of the formation of a complex which is CuNH3 4 times OH twice. Now CuNH3 4 times is a coordination entity, so I have enclosed it in square brackets, and the hydroxide ions are acting as counter ions. Now this is known as tetraamine copper hydroxide. Tetraamine copper hydroxide. That is the chemical name. This is, however, commonly known as Schweizer's reagent. It is known as Schweizer's reagent in common terms. But the IUPAC name is tetraamine copper hydroxide. And you actually will be learning about nomenclature of coordination compounds in the chapter coordination compounds, which is in the grade 12 chemistry syllabus. The white precipitate which is formed is actually cadmium hydroxide, CdOH twice. Then the yellow precipitate formed here is cadmium sulfide, and this chocolate brown precipitate is copper ferrocyanide. So ferrocyanide is actually it is a coordination entity, and it is an anionic species because it is having a charge of -4. If you see ferrocyanide, it is having a charge of -4. So when you are balancing it with a counter ion, you need to ensure that there are four atoms which are having a +1 charge. That is why when you're using potassium, potassium has a charge of +1, which is why we need to use 4 potassium atoms in order to form a stable species. Now, this is known according to IUPAC nomenclature, it is actually hexacyanidopherrate. Hexacyanidopherrate, and the charge of iron is 2. So this is the name of this compound, but according to IUPAC nomenclature, but commonly we call this this coordination entity as ferrocyanide. So that is all about the group 2 confirmatory tests. Now we need to go to group 3. Now if you remember, I told you for groups 3, 4 and 6 we can use the ash test, and I had explained before about the procedure for the ash test. So now we need to see what is the observation. Now, even though we can use the ash test for 3 groups, the color of the ash is different for all of them. So, what is the color for the group 3 cation? We need to discuss. So, for group 3 cation, that is aluminium, the first test that we can do is the ash test. I told you the procedure already. and I told you we will get an ash at the end of the procedure. Now if the color of that ash is blue, if you are getting a blue ash, that means group 3 cation is confirmed. Now, the ash that is formed has a molecular formula of Al2O3.COO, and it is commonly known as Thenard's blue. Okay, Thenard's blue is the common name, and the IUPAC name of this would be cobalt aluminate. Cobalt aluminate. I will write that. Cobalt aluminate. That is the IUPAC name. The common name is Thenard's blue, and it is blue in color. The ash is blue. Now, there is a second confirmatory test other than the ash test. Now, that involves the precipitate. So, now you know that there is a group precipitate formed at the end of the identification test. If you remember, it was aluminium hydroxide. Now, to that group precipitate, you need to add dilute HCl. Dilute HCl is the solvent that we are using to dissolve the precipitate. Once you add dilute HCl, you need to add around 2 drops of blue litmus. So you will be having blue litmus in the form of a solution in the lamp. So you need to add 2 drops of blue litmus solution, and also you need to add 2 drops of ammonium hydroxide NH4OH. When you are doing this, if you are able to observe a blue colored precipitate floating in a colorless solution, a blue precipitate floating in colorless solution, then that means aluminium ion is confirmed. And this test is known as a blue lake test, because you are getting a blue precipitate in a transparent or a colorless solution. And this blue precipitate which is formed is actually still aluminium hydroxide. We are starting with aluminium hydroxide and we are also ending with aluminium hydroxide. But if you remember, I told you that aluminium hydroxide is a white and gelatinous precipitate. I had mentioned that in the identification test. So how is this blue precipitate also aluminium hydroxide, you may wonder. So that is because of the blue litmus. So actually the blue precipitate is not blue in color, it is white in color. However, due to the addition of blue litmus, the white color changes to blue. So that blue precipitate is still aluminium hydroxide. It is still a white gelatinous precipitate, but it appears blue because we are adding blue litmus. That's all about group 3. Now we can move on to group 4. Again, for group 4, we need to discuss about the ash test first. So in group 4, we have zinc and manganese, but I am not discussing manganese because manganese is a colored salt, and also it is not something which is commonly asked in the exam. But in your school, if they are discussing manganese, then please let me know in the comments and I will upload a video for manganese ion. Now in group 4 we have zinc, and first we can of course perform the ash test. Now for the ash test you are going to get an ash, and for zinc ion the color of the ash would be green in color. It would be green. Now the green ash which is formed has a formula of ZnO.COO. The IUPAC name of this is cobalt zincate. Cobalt zincate, and it is commonly known as Rinman's green. So the common name of this is Rinman's green. Now the second test involves the group precipitate. Okay, now the group precipitate, we need to take it. And what is the solvent that we are using? Again, the solvent is dilute HCl, just like the previous one. Now, after adding dilute HCl, you need to add another chemical which is sodium hydroxide, and this should be added drop by drop. When you're adding it drop by drop, you will slowly see that a white precipitate will start to form. So the white precipitate which is formed is actually zinc hydroxide. Now, very important, when you're adding excess amount of NaOH, what happens is the white precipitate will be dissolved. So, the white precipitate that is formed, which is zinc hydroxide, will be dissolved in excess NaOH. And the precipitate which is formed, it is actually going to dissolve and form sodium zincate. So the zinc hydroxide dissolves to form sodium zincate. Sodium zincate is Na2ZnO2. That is sodium zincate. Now there is a third test which you can do, and that is you have to use the salt solution, not the precipitate, just the salt solution, and you need to add potassium ferrocyanide. And when you're doing this, if you're getting a pale yellow precipitate, or it is actually a white precipitate, but it would appear kind of yellowish. So if you're getting a pale yellow or a white PPT, that means zinc is confirmed. And the reason why you are, the precipitate that is formed is actually Zn2FeCN6, that is zinc ferrocyanide. Next we have group 5. Now for group 5 we have the cations barium, strontium and calcium. Now, very important, you need to first understand the flame test. What are the colors imparted to the flame? Now, I explained the procedure to do the flame test. Now, once you are conducting the flame test, you would observe a characteristic color imparted to the flame if the cation is a group 5 cation. Now, if your flame turns pale green in color, that means the cation is barium. If a crimson red color is imparted to the flame, then strontium is your cation. And if a brick red color is imparted to the flame, that means calcium is your cation. Now I will try to show you the colors of the flame with the help of this spectrum that I have on my tab. So the pale green color would kind of look like this. This is the pale green color. I'm not sure if you can see it. I will zoom in. So if you're able to see, this is the pale green color that you would observe. The crimson red color the crimson red color is actually a very dark shade of red. So it would be like a pinkish red. So if I were to describe the crimson red color, I think this is the color. Yeah, this is crimson red. Of course, the flame won't be as dark as this. The flame will be getting a very light hint of the color, but it would be a shade of this color what I'm showing you on the screen. Now the brick red color is actually kind of orangish. So if I were to show you brick red, It is like orangish red. So I think something like this. No, not this. This is not brick red. Brick red is kind of like orange, but it's having a shade of red. Mm, Let me just, yeah, this is brick red. So this is brick red. Again, the intensity of the color in the flame would be quite low. It won't be a very dark shade of brick red, but the color is this. Okay. So I hope that's clear to you. Now let's discuss the other tests. Now the confirmatory test that you need to perform involves the precipitate. And if you remember in the identification test, I told you we need to identify the cation by performing the confirmatory test because all the precipitates are white in color. So now we need to take the precipitate and dissolve it in a solvent. And the solvent that we use here is acetic acid. Now, since acetic acid is a weak acid, you would have to heat it so that the precipitate boils in the acetic acid solution. And once you heat it, you need to divide it into three parts. So you have to divide it into three parts. So to the first part, you need to add potassium chromate. To the second part, you need to add ammonium sulfate. And to the third part, you need to add ammonium oxalate. Oxalate is an ion which has a -2 charge. It is C2O4 2 minus. Actually, oxalate is nothing but it is oxalic acid. If you know, oxalic acid is a dicarboxylic acid. What we are doing is we are removing the two hydrogens by cleaving the OH bond, and we are getting an ion which is actually oxalate. So this is the structure of oxalate ion, and this is the molecular formula. So now let's discuss the tests. So when you're adding potassium chromate to the first part, if you're getting a yellow PPT, that means barium is your cation. If you're getting a white precipitate when you're adding ammonium sulfate, that means strontium is your cation. If you're getting a white precipitate when you're adding ammonium oxalate, that means calcium is your cation. Now, the strontium test would be quite slow because you will not see the precipitate immediately. So, you need to wait for a minute or two for the precipitate to form. So, before moving on to calcium, wait for 1 or 2 minutes and see whether the precipitate is forming. If you want to make the process faster, you can heat the test tube so that the precipitate is formed easily. Or you can even place it on a water bath. Now, what you have to do is we need to now learn the precipitates formed. Here the precipitate formed is barium chromate. Here the precipitate formed is strontium sulfate. And here the precipitate formed is calcium oxalate. So that is the confirmatory test. Now there is an additional confirmatory test only for barium, and that involves the yellow precipitate formed. So for the barium ion, you can actually take the yellow precipitate and you need to add concentrated HCl to it, and also you need to add dilute sulfuric acid, dilute H2SO4. And when you're adding these chemicals, if you're getting a white colored precipitate, that is also another confirmatory test. And this white precipitate formed is BaSO4, barium sulfate. And also another thing that you need to know is this white precipitate which is formed, that is barium sulfate, is actually obtained by a double displacement reaction because you're adding H2SO4. So the ions are interchanged, which is why barium will react with the H2SO4 to form barium sulfate, and you will get H2CrO4. Okay. Now we need to discuss another thing, that is about the color of the yellow precipitate. The color of the yellow precipitate is going to be a very light or a pale shade of yellow. Now, potassium chromate itself is a yellow chemical. So when you're adding potassium chromate to anything, you will see a yellow color. So please don't get misled by the yellow color of the solution. The precipitate that is formed should not be a dark yellow color. The dark yellow color is simply because of the K2CrO4. If you are getting a yellow precipitate, you will notice a solid residue being formed, and it is going to be a very pale shade of yellow. And let me try to resemble that using my color spectrum. So the pale yellow PPT would look something like this, exactly like this. This is going to be the color of your pale yellow precipitate. I hope you can see it. This is going to be your pale yellow PPT's color. So please note that this should be the color of the PPT. If you're just getting a dark yellow color, that is because of potassium chromate, not because of a yellow PPT. So please don't get misled. Now we need to learn the last cation, which is group 6. Now for group 6, that is magnesium, we can first perform the ash test, and the color of the ash for the ash test would be pink. You will get a pink colored ash. And the ash has a formula MgO.COO, and it is called cobalt magnesiate. And there is no common name, or I am not aware of the common name, and I don't think there is a common name for this, but the IUPAC name is cobalt magnesiate, and it is pink in color. Now we need to do the confirmatory test. For the confirmatory test, actually you should use the salt solution for group 6, not the precipitate. So you need to take the salt solution and add NH4Cl, NH4OH, and also you need to add sodium phosphate, that is Ne3PO4. And if you are getting a white crystalline PPT, that white crystalline PPT is magnesium phosphate Mg3PO4 twice, and that confirms the presence of magnesium. Instead of sodium phosphate, you can actually even use ammonium phosphate. It will give the same result. With that, we come to the end of the confirmatory tests and the salt analysis. However, I will be doing a 5th part soon, where I will be discussing viva questions for salt analysis. But with this, we are done with the procedure of the salt analysis experiment. It was very lengthy, but it will be easy once you practice, and surely with time you will get used to all the tests and the observations. So thank you everyone, and have a great day, and I'll see you in my next video. Thank you.